A body is pivoted at a point. A force of 10 Newton is applied at a distance of 30 centimeter from the pivot. Calculate the moment of force or torque about the pivot. So this is the diagram we can make here, and force is applied here. This is, I am assuming that it is applied like this. So the moment of force, if you see, it will be like this way. It will move anti-clockwise, or we can say out of the page by the right hand rule. Here I've converted it into the meters because the distance was given in centimeters. You can say, we can say zero point 0.3 meter directly, or we can say 30 into 10 raised to power minus 2 meter. So that way we will calculate it. We'll just use the formula of torque and we will get the moment of 3 Newton meter. Newton meter is the unit of moment of force or torque. So this will be the magnitude because direction I have chosen. I have made this diagram. So if force is like this, our moment will be anti-clockwise movement or out of the page. Second question, the moment of a force 5 Newton about a point P is 2 Newton meter. So in this case, the moment of force magnitude is given to us already. Calculate the distance of point of application of the force from the point P. The distance they are asking. So we are just using the formula. So the torque is given as 2 Newton meter, force is given as 5, but D is unknown. We don't know this. So we'll apply this. F into D, 5 into D is equal to 2 Newton meter. It has to be. Then D will be 2 divided by 5, which will come as 0.4 meter. So the distance is 0.4 meter from the pivot. A mechanic can open a nut by applying a force of 150 Newton while using a lever handle of length 40 centimeter or 0.4 meter. How long handle is required if he wants to open it by applying a force of only 50 Newton? Now he wants to apply lesser force. He was applying 150 and he wants the 50 Newton force only to be applied. Intuitively we can also do this question like 150 to 50, we are decreasing it, reducing it by 1/3. So distance has to be 3 times. So distance is 0.4, then it will be 3 times 1.2 meter. But by formula, how we can do it? Let's see. So this is the pivot. It's pivoted here, so 0.4 meter, and this is the 150 Newton. I have imagined like this is the force we were applying. So we can get the same moment by 50 Newton, but we have to calculate what will be the distance. That's the question. So the moments should be equal, right? We should be, even with this force, he should be able to open the nut. So that's why the moments will be equal. Whatever the moment was getting generated here will be equal to the a movement created by the lesser force. So we will equate this, and then solving this will get answer as 1.2 meter. The iron door of a building is 3 meter broad. It can be opened by applying a force of 100 Newton normally at the middle of the door. Okay, at the middle of the door, remember that the point of application of force is middle of the door. If it is 3 meters, so 1.5 meters we are applying a force. Calculate the least force which can open the door. So least force we can apply when we go as far as we can from the pivot or the hinges in case of iron door. Where should the force be applied? The answer is we should apply it at the end. So let's see, this is the top view of the door. So this is the door and this is the pivot or hinges, we can say, or pivot we can say, and we are applying at the middle. Remember that. So that is what they have given. So we can open this door by applying this, doing this, F of 100 Newton at the middle. So the moment required to open the door, we can calculate from it, from here. So 100 into 1.5, remember, because it is the middle point. So the distance till here will be 1.5 meter only. So we can do torque is equal to 100 into 3 by 2 or 1.5. That will be 150. So this much is required. Torque is required to open this door. Now, same moment we can get if we apply force at the end of the door, because we want to apply least force, right? So that's why we are going farther. We will not apply force here. We'll apply force at the end here. In that case, I'm made this diagram now. So now if we are applying a force like this, let me put the same direction of force like this, and we want to open this door. So now our moment will be F into 3, F into 3. But because the door needs the same moment as it was having it before, we will equate with the previous moment of force of the torque value. So 150 will be equal to F into 3, and we can calculate it is like 150 divided by 3 will be 50 Newton. So if we see in this question, what they are asking is the least force where we need to apply it. So for the least force is where we get maximum torque. We can increase the distance to do that, and that's why we have done. We are applying force here. We have increased the distance so that we get more rotational effect even with the lesser force. The wheel shown in the diagram, here is a wheel shown in the diagram, has a fixed axle passing through O. So this is the O. So it's fixed. This part will not move. Okay. The wheel is kept stationary under the action of a horizontal force F1. This is the force F1 at A. This point is A, and two, a vertical force F2 at B. F2 at B. But F2 is not given in this diagram, like which direction it is. Okay. A, show the direction of F2 in the diagram. So which direction we should apply the force F2? B, which of the force F1 or F2 is greater? Which force will be greater? C, find the ratio between the forces F1 and F2, and the values are given. See, AO, this length is given to us. So we can calculate the moment created by this force because this is known to us. So F1 into OA, that we know. And that will be the radius of this, we can say. And BO is also given. BO dash is given to us, and OO dash, this distance is also given to us. Okay, now where we can apply force? First thing is, this force is going to rotate like this. So to compensate that, to cancel that, I need a force which is in this direction, right? So the torque should be in this direction, or in a way, F1 is creating a clockwise movement. I will apply a force in a direction which will be creating the anti-clockwise movement to balance this movement due to this force. So what will be the direction? Now first thing is, just hear this question out again. A vertical force F2. Okay, so the F2 force is vertical. So this was an important point because we can, imagine like this also, or we can imagine like this also F2, right? But they are saying it is vertical. So either it can go up or either it can go down. So in our case, we will apply like this. Why? Because doing so will be creating anti-clockwise movement. And this force is creating clockwise movement. So there is a chance they will cancel and balance each other. So this was, they were asking like which direction it will be. Let's see the solution, detailed solution of this. So see, the direction of F2 will be downwards. See, B option, F2 has to be more as it is acting closer as compared to F1. See, this force was acting on this end. Okay, so note down, to calculate its moment, we have to multiply this much distance, OA. Now think about it. If we are applying F2 vertically like this on this line, so distance will be less, right? So if we keep it same, the moment will be less of this force. So this has to be more. So this F2 has to be a bigger arrow. It has to be more as compared to this one because distance at which it is acting is less. So to compensate that, we have to have more force F2. Okay. See, what we are doing is we can compare anti-clockwise movement to clockwise movements. So we will get this relation, and we can solve for the ratio of F1 and F2, and we will get the answer as 0.8. So you can solve it by yourself. It's very simple, just simple math. Now again here, if you see the answers, of Selena book, they have given the ratio differently, and I have taken the answer differently. So the ratio is what I will say is 4 ratio 5, right? Because F1 and ratio F2 is been asked, but they have given 5 ratio 4. But both answers are correct. What we do generally is how it has been said in the question, we will take the same sequence. Because they ask ratio of F1 and F2, we will take F1 and F2 like that. This is the, generally it is followed. But in case of, if you take F2 first, then it will be 5 ratio 4. So that is why it is a little different, as your answer will not match in the answer book. So please don't worry about it. We have to find the ratio between these forces, and that you have found it. So don't get confused. But baseline is always take the sequence which is mentioned in the question. If it is ratio, find the ratio of F2 and F1, we will take F2 divided by F1. If it is asked like ratio of F1 and F2, then we will take the same ratio. Generally, we follow that. Okay. The following diagram, this diagram shows two parallel and opposite forces. So there are two parallel forces. This is 5 Newton force. This is 5 Newton force. We are saying a different name by this so that you understand that this is acting above and this is acting below. But if you see, the magnitudes are same, but their directions are different. That's why we are treating them as a different force. Okay. With their lines of action separated by a distance of 2 meter, they are separated by 2 meter. This one, a point X lies midway. So this is the midway, or 1 meter from here or 1 meter from here. A point X lies midway between F1 and F2, while the point Y lies on F2. It lies here. A, calculate the total movement of the two forces about X and Y. And B option, state the effect produced by the two forces about the point X and point Y. Let's do first about X and then we'll do about Y. So see, about X, a couple is acting. If you see this X and two forces equal and opposite, see this force equal, opposite line, not line of action is not same, they have a separation. So a couple is acting around this couple, so we can calculate the torque due to the couple. And remember, for couple, the torque is given by force multiplied by d, where d is the separation or perpendicular distance between two forces. So it is not the distance from the pivot. So remember that. Okay, so that is the catch when we are dealing with the couples. So here we can apply that. 5, the distance between two forces is 2. See, this one force, the distance is 2. So the answer will come as 10 Newton meter. Okay, now let's do the next part. About Y, what will happen? No effect of F2 as passing through the pivot. As F2 is passing through the pivot, so it will not, F2 will not affect this. The only movement will be of F1, and that we can calculate. 5 into 10 is equal to 10 Newton meter. Let me explain you what we want to say here. See, in this diagram, we have to ask the moment about this, but this force is acting on the pivot. If you are pivoting this, if you are fixing this, no matter what, how much force you apply, this force will be redundant. It will not be able to do anything, or it will not produce any moment for this point or about this point, and this will produce. But how much? The force multiplied by the perpendicular distance. So this is a single force which is acting. It is not a couple in this case, as if we were doing in the case of X. In the case of Y, we will calculate force multiplied by the perpendicular distance from the pivot, which is 2. But if you see, in both cases, we are getting the same torque or same magnitude of movement of force.